Welcome, Math 136 students, to the Module 02A Problem of the Week. So in this week, I know that one of the things you'll be asked to do is work through story problems, and I know that if I were to make a top 10 list of types of problems that students really didn't want to do, one being the one that students absolutely despise, I would say that story problems would rank very high on that list. So I thought, why not approach this story problem? What we have here is a problem where we're looking at these two pumps and they are working to complete a job together. So this is a type of problem where again you got two things, in this case pumps. Sometimes the problem involves people where you're doing a job together. I actually have another problem similar to this, and I'm going to put the link in the top right hand corner of this video right now, where you are going to do where I work through a problem that's similar to this but not identical. In this problem, we have an oil tanker that can be emptied by a main pump in 5 hours. An auxiliary pump can empty the tanker in 9 hours. If the main pump starts at 1 p.m., when should the auxiliary pump be started so that the tanker is emptied by 5 p.m.? I've created a table to help organize our thoughts as we work through this problem. The first thing I'm asking you is how many hours does it take for each pump individually to do the job, to drain the tanker? So the main pump will take 5 hours, whereas the auxiliary pump will take 9 hours. Now I'm asking for how much of the job can be done in 1 hour. Well, if it takes 5 hours to do the full job for the main pump, then 1/5 of the job will be done in 1 hour. Likewise, if it takes 9 hours for the auxiliary pump, then 1/9 of the job will be done in 1 hour. Now time, and what I mean by time is how much time will the pump need to complete this job if we go from 1 p.m. to 5 p.m. Well, the main pump it's starting at 1 p.m., it's stopping at 5 p.m., so the main pump is going to be on running 4 hours to complete the job. The question is, at what point do we start the auxiliary pump so that it can work and help the main pump to complete this job? Well, we don't know, and that's the question we're supposed to be asked, or we're supposed to answer. And as a result, we don't know how long the main pump, or sorry, the auxiliary pump is running. So we're going to call that T, as in the time that the auxiliary pump is running, which will then allow us to figure out at what time the auxiliary pump needs to start running. So what we're going to do is start and look at the rate for the main pump, and I'll call this main, for the main pump, and we're going to multiply that by the time the main pump is running. So this is going to give us the portion of the job that the main pump is doing during that time that it is running. We're going to add to that the rate of the auxiliary pump times the time the auxiliary pump is running. And again, what this will do is give us the portion of the job that the auxiliary pump is doing over the course of the time that it's running. And then so then it's going to be equal to 1, as in the full job or 100% of the job is complete at that point. So now let's go ahead and replace the rate and time for each of these with any values or variables that we have. So what we know is that the rate for the main pump is 1/5, and the time for the main pump is 4 hours, or 4. The rate for the auxiliary pump is 1/9. The time for the main pump is the unknown, so we'll call that T, and so it's equal to 1. So now we have an equation and we need to solve this for T. So we'll start by multiplying 1/5 times 4, which is 4 over 5, plus, and I'm going to go ahead and multiply 1/9 times T, so that'll be T over 9 is equal to 1. Now I subtract 4/5 to both sides, and I get T over 9 is equal to positive 1/5. Now I'm going to go ahead and cross multiply, or I actually think just multiplying both sides by 9 is a good strategy, which then allows us to get, and I'm going to put it up here to the right, allows us to get T is equal to 9/5. What I'd like to do now is convert that over to a mixed number. So in a mixed number format, that'll be 1 and 4/5, which I can rewrite also as a decimal as 1.8. So this is 1.8 hours. So that's the first part. Now we have a time. That's how much time the auxiliary pump needs to be running in order to support the main pump to complete this job by 5 p.m. But at what time do we need to start the auxiliary pump? Well, to do that, we're going to work backwards from 5 p.m. So we know that the time that this all needs to be complete is 5 p.m. I'm going to start by subtracting the 1 hour from 5 p.m. so that'll be 4 p.m. Now I need to figure out how many hours, or rather how many minutes, is zero point 0.8 hours. So I'm going to take 0.8 hours times 60 minutes, or 60 minutes over 1 hour. So basically I'm converting this over to minutes, and so the hours units cancels out, and what I realize is that this is equal to 48 minutes. And so now I'm going to take that 4 p.m. and I'm going to subtract from it 48 minutes, and so what I get is 3:12 p.m. So the auxiliary pump needs to start at 3:12 p.m. in order for the pumps to work together to complete this job by 5 p.m. All right, so I hope that that helps. And again, I've got several other videos working through the other types of story problems that should be embedded in your course. And good luck. I hope that this was helpful.